Alright then, so here we are again on Mathelingual, and Mike's still going. Great, okay. So I cleared off the board. We just went over properties, so now let's delve into some actual examples, because I find you never really can say you understand a concept in mathematics until you actually apply it, right? It's like with science too. So first example is 7x squared plus 3y squared plus 2y squared minus 4x squared. Now, last week I discussed like terms. We are going to apply that principle here along with a few others. So first off, identify the like terms. Look for the ones that have the same variables and the same powers. So we've got two y squared terms and we've got two x squared terms. Okay, we've done that. Now we just rearrange them based on that, because it's easier to compute when they're next to each other and not like on opposite ends of the expression. So, okay, 7x squared minus 4x squared plus 3y squared plus 2y squared. All right, so technically we are able to do this by the commutative property of addition, right? You just move some things around, but you're not changing anything except how you write them, like the order in which you write them. Now we're going to use the distributive property a little to factor out 7 minus 4 times x squared, because you realize, yes, we're used to, up to this point, we're used to seeing the single term on the left side of the parenthetical expression, but it goes both ways because it is just multiplication. And you can still put it here and it works. So 7 minus 4, because that's the coefficients, x squared, plus, we're going to do the same thing over here, 3 plus 2 times y squared, because that's really all you're doing when you combine like terms. You are computing their coefficients, okay? So we've got 7 minus 4x squared plus 3 plus 2 times y squared. That is using the distributive property, and now we're going to just combine like terms. 7 minus 4 is 3, so you get 3x squared. 3 plus 2 is 5, so you have 5y squared. And that is how you simplify this monster of an expression into two little terms. That's it. Okay? Good on that? I think we are. 3x squared plus 5y squared. So now I'm going to go to another example I need some notes on. And this one is a little bit more challenging looking because it's got other letters. So remember, variables, you can use any letter. X and Y are really common, but you can, in theory, use any letter. Okay, so example 2, we have the opposite or negative sign times the quantity 3k plus m plus 2 times k minus 4m, okay? So we're still going to think about how we're going to solve this. So using the opposite of a sum, so that, you know, when you have this negative sign outside a sum, and then we're going to also apply the distributive property over here as well. So to simplify, this is negative 3k minus m, okay, plus 2k minus 8m. Because remember, when you're distributing, that outside term is going to go to everything. So really, like this negative 1, you can also think of this as an application of the distributive property, because it is really just a negative 1 that is going to each of these two terms in parentheses, okay? So, you know, negative 3k from negative 1 times 3k, negative m from negative 1 times m, 2k from 2 times k, negative 8m from 2 times negative 4m. And now you just combine like terms. So first we look at our like terms as we did in the first example. So negative 3k and positive 2k, negative m and negative 8m. So you simplify that. That is negative 3k plus 2k minus m minus 8m, and that is negative 3 plus 2k, okay, minus plus, I guess, negative 1 minus 8, right? Because this is really, it's really like if you were just adding this part times m. So that is negative k, right? Because negative 3 plus 2 is negative 1, but you don't really write negative 1. You just put a negative. It's understood you're talking about just one of those terms. And then negative 1 plus negative 1 minus negative 8 is negative 9m. So we can simplify this, and we get negative k minus 9m for our final answer. And that also gives you an idea of how you work when you have a lot of negative signs going around, because I think the problem starts with some of these problems is when you start distributing and you've got negatives and you've got subtraction to deal with, because it gets a little weird at times. But I think you just go through the basic steps one by one. Most importantly, you have to do this very methodically. You have to follow out this, you have to see through this process. You can't just buzz through it and think like, oh, I know this and yada yada. It's important because in mathematics, you mess up on one step, it is going to affect your whole answer at the end. So again, this is the final result from this original expression, negative k minus 9m. So that concludes it for this video. Next video, I'm going to talk about a couple properties again, kind of like how I have for these last two videos, but now we're going to touch base on equations. So see you then.